Today, we will be covering every topic needed in non-relational databases, including MongoDB, Cassandra, Redis, and Neo4j. Stick your butts in one place. Let's start. Modern applications don't fail because SQL is bad. They fail because the assumption SQL was built on, single machines, predictable schemas, and centralized control, do not hold at internet scale. When systems need to handle millions of users, global traffic, and constant change, traditional relational constraints become bottlenecks. This is where non-relational databases, or NoSQL, enter system design. A non-relational database is designed to operate in distributed environments. It does not enforce rigid schemas, avoids join-heavy relationships, and scales horizontally across machines. The goal is not relational integrity, but operational scalability, availability, and flexibility. In short, NoSQL databases are optimized for how data is accessed, not how it is structured. At web scale, system design is dominated by a different class of problems. Modern applications need to handle millions of writes per second, support geo-replication, and evolve schemas without downtime. Relational databases struggle here. Sharding data becomes complex and error-prone, join-heavy queries break down at scale, and write throughput collapses under a single leader. NoSQL systems respond by removing joins, decentralizing writes, and relaxing relational guarantees to survive distribution. The core insight is simple: NoSQL trades, relational guarantees for scalability, and availability. NoSQL databases are not a single technology. They are a family of data models designed around access patterns. Key value stores map a unique key to an opaque value, enabling extremely fast reads and writes, commonly used for caching and session storage. Document databases store self-contained JSON-like documents, allowing flexible schemas and making them ideal for user profiles and content-driven systems. Wide column databases organize data into column families, optimizing for massive write throughput and large-scale analytics. Graph databases model data as nodes and relationships, excelling when querying complex connections like social graphs or recommendations. The choice depends entirely on how the data is accessed, not how it is conceptually related. NoSQL should be used when scalability and availability are primary system constraints. If your application handles massive read or write throughput, needs to scale horizontally, or must operate across multiple geographic regions, NoSQL becomes a natural fit. It is especially effective when schemas evolve frequently and access patterns are simple and well-defined. However, NoSQL should be avoided when strong transactional guarantees, complex joins, or strict correctness are mandatory. In practice, most large systems use NoSQL selectively, only where relational guarantees become bottlenecks. Here is the in-detail flowchart of which database to choose. You need ACID properties, go with relational DB. You have to put many queries, go with document type DB, else column-based database are best for horizontal scaling. Now in the next few sections, we will talk in detail about the technologies used as non-relational databases. I will make sure to give important details on the DB. Let's go with MongoDB is a document-oriented, NoSQL database designed for application-driven data. It stores data as JSON-like documents, allowing flexible schemas that evolve with the product. MongoDB achieves scalability and availability using replication and sharding. Replication is implemented through replica sets, where one primary node handles writes and multiple secondary nodes replicate data asynchronously. If the primary fails, an automatic election promotes a secondary, ensuring high availability. Sharding enables horizontal scaling by partitioning data across multiple shards or kind of servers using a shard key. A query router, called Mongos, directs requests to the correct shard, allowing MongoDB to scale reads and writes transparently. Replication keeps MongoDB alive. Sharding makes it grow. MongoDB should be used when your application data is naturally document-oriented and the schema evolves frequently. It is ideal for systems like user profiles, content platforms, and APIs, where related data can be embedded and accessed together. MongoDB works well when horizontal scalability is required, but complex joins and strict transactional guarantees are not. In short, MongoDB optimizes developer speed and scalability by trading relational rigidity for flexible document design. Apache Cassandra is a wide-column NoSQL database designed for massive scale and high availability. It uses a ring-based, peer-to-peer architecture where all nodes are equal, eliminating single-leader bottlenecks. Data is partitioned using consistent hashing and distributed around the ring, then replicated across multiple nodes for fault tolerance. As a wide-column store, Cassandra organizes data into column families, optimized for write-heavy and time series workloads. This design makes Cassandra highly resilient and always available, but it intentionally trades strong consistency for scalability and fault tolerance. So when to use Cassandra? It should be used when availability and write scalability are more important than strict consistency. It excels in systems that handle massive write volumes, operate across multiple regions, and must remain online during failures. Cassandra is well suited for time series data, logging systems, and large-scale event storage. However, it should be avoided when queries are complex, access patterns are unpredictable, or strong transactional guarantees are required. Cassandra is built for systems that must never go down, in any case, just like Discord. Now, Redis. Redis is an in-memory, key-value NoSQL database designed for ultra-low latency access. All data is stored primarily in memory, allowing reads and writes in microseconds. Redis supports rich data structures such as strings, lists, sets, and hashes, enabling simple computations close to the data. It can replicate data for high availability and persist snapshots to disk, but speed, not durability, is its primary goal. Redis is optimized for fast access, not complex querying or large-scale storage. When to use Redis as a non-relational DB? Redis is a cache and coordination tool, reduces load, not complexity. Memory is the bottleneck, usually paired with SQL or NoSQL databases. Redis should be used when performance and latency are the dominant system constraints. It excels as a cache, session store, rate limiter, or real-time counter in front of slower databases. By offloading frequent reads and writes, Redis protects primary databases from load. However, Redis should not be used as a primary database for large or highly durable datasets due to its memory-based nature. In most systems, Redis complements databases. It does not replace them. Redis trades durability for speed, intentionally. Neo4j is a graph-based NoSQL database designed for relationship-centric data. It stores data as nodes connected by edges, where relationships are first-class citizens, not derived through joins. Queries are executed using graph traversals, making multi-hop relationship queries efficient and intuitive. This design allows Neo4j to model complex connections naturally, but it prioritizes relationship depth over horizontal scale. Neo4j is optimized for understanding how entities are connected, not for high-throughput transactional workloads. If you are still there, listening, congrats. Now you know everything about non-relational databases. Make sure to subscribe. Peace out.